Alright, welcome ladies and gentlemen. This is Pre-AP Algebra 1 Quadratic Functions Unit, Lesson number 2. Please notice announcements on the board. Lesson 3 is now due. Deadline for remediation points is April the 4th. Remember, we have 2 categories and you fall into one of the 2. So please make sure if you're in the range of a 69 to 60, you get those test corrections turned in as soon as possible. If you fall in the range of a 59 to a 0, you have to turn your corrections in and come in and take the retest. So that's a 2-step process and you have until Thursday, April the 4th. Please make sure you get that done. Go ahead and pause the video and get yourself ready, get you some notes out, and I'm going to go ahead and get started. So today's lesson, lesson 2, is going to be all about finding zeros. So let me touch base with you on what exactly I'm talking about before we jump into what the first discussion today. Zeros are going to be where does your function that you're graphing cross the axis, because the axis are where we find the zeros. This is your y-axis, and I have a 0 right here known as your y-intercept. And that is going to be where x equals 0. I also have what's known as your x-intercepts, the axis where it crosses the x-axis, which is going to be these 2 points right here. They're called the x-intercepts, and that's going to be where y equals 0. So first off, when we refer to zeros, you need to make sure that you're connecting with the idea that we're looking at where does the function cross the axis. And in this problem, we actually have 3 intercepts. We've got 2 x-intercepts and we have 1 y-intercept. Now, to connect with you on what's about to happen, there are 3 possible types of solutions. Or let's just go ahead, let me back up. Let's just talk about the y-intercept. Okay, y-intercept first. Where does it cross the y-axis? Now, y-axis, as we learned last class time, sometimes is visible when we put it in our calculator, sometimes it's not visible. We're very familiar with the y-intercept when it's a line, so let's talk about y-intercept when it's a quadratic. First problem I want to look at is this one. When you have a quadratic that's in standard form, your y-intercept is going to be the constant, or the number without the letter. So pretty much when it's in standard form, these are the easiest problems in the set. Your y-intercept is going to be the ordered pair, y-intercept being where x is 0. Your y-intercept is going to be at -20. So because the y-intercept is an ordered pair, we answer in ordered pair form. So the first problem in the set is the easiest problem when it's in standard form. Your y-intercept is the c, or the constant, the number without the letter. When we get to the second problem today, it is not in standard form. It's in what we call factored form, or a version of factored form. So what we have to do is put it into standard form, meaning we're going to have to do distributive property right here. So we're going to get 42 equals 13x minus x squared. And then, of course, one of the features of a quadratic, I don't know if you noticed back over here, but your quadratic always equals 0. So that's the characteristic we want to meet. Now, what I'm saying is we want to set this equal to 0. Okay, sorry, got interrupted, so now I need to find myself again. All right, so we've just done distributive property over here, and because it's a quadratic, because I have an x squared in my problem, I have to set it equal to 0. The other thing you want to keep in mind right here is you want to make sure your quadratic coefficient, or your a, is positive. So the other thing we need to consider is to make /keep a positive. So what that means for me is pretty much when I go set this equal to 0, I want to move both of these terms right here to the other side. So my 42 is going to stay positive. I'm going to subtract the 13x, and I'm going to add the x squared to get my quadratic in standard form. And of course the whole goal is to find the y-intercept, and once we get it in standard form, you can see that my y-intercept is a positive 42. So the answer is 0, 42. Please feel free to pause, but I'm going to go ahead and move on to the next problem. Next problem in the set is in what we call factored form. In other words, if we were to do distributive property or that FOIL acronym, we would end up with our quadratic in standard form. So that's how we have to go find the y-intercept. We're going to have to do the FOIL. So the first thing I'm going to do is distribute the x to both terms, and I'm going to get the x squared minus 8x. And then I'm going to go distribute the 4. So I'm going to get the 4x minus 32 equals 0. Of course, you can go ahead and combine your like terms right here, but that really doesn't matter because we have the one piece of information we need. It's right here. My y-intercept is negative 32. So the answer is 0, negative 32. The question is specifically asking you for the y-intercept. Next problem in the set is exactly the same. We've got to do FOIL, i.e. distributed property, to find the y-intercept when in factored form. So I'm going to distribute the 2x, and that's going to give me a 2x squared plus 14x. I'm going to distribute the 5, which is going to be the minus 5x minus 35. Y-intercept is the ordered pair 0, negative 35. Please feel free to pause, but I'm going to look at the last few problems in the set, and then we're going to have some work time. So this is the end of part 1. Again, we've got quadratics. The only reason we know it's a quadratic is because it has a squared term in it. Now these are a little tricky, so I'm going to go a little slower. We cannot assume that this is the y-intercept because this is not in standard form. Okay, let me say that again. 4 is not the y-intercept. It is not in standard form. It is in what they call transformation or vertex form. So we're going to have to go through and do the math to get it into standard form. The first math we need to consider is the exponent. According to order of operations, we got to simplify inside, and since I don't know what x equals, I have to go to the exponent. The exponent tells me to stamp this binomial out twice, so it looks like this. And then of course you can see I've got to do FOIL, which was just like the problem set that we just did. So I'm distributing the x, and now I'm distributing that negative 1. Negative 1 times negative 1 makes a positive 1. And I'm going to bring down the plus 4 in my problem. Here is an example where we have to go through that next step of combining like terms. So I'm going to get an x squared minus 2x. I'm going to combine these two and get a 5, which takes me to my answer. The y-intercept is at 5. Okay. Trick with these when they're in what they call vertex or transformation form is to follow order of operations. Again, order of operations, since we don't know what x is inside the parentheses, it's time to go to the exponents. So here I go. I'm going to go ahead and write down the negative 2. Order of operations, this exponent right here tells me to stamp out this group twice. So this is an example of a problem where I start working and it actually turns into a little bit bigger of a problem. Of course, now we have to do this multiplication first. So I'm going to go ahead and do distributed property with the x and get the x squared plus 3x. Distributed property with the 3 and get the 3x plus 9. And now I've got to continue to follow order of operations, which means I have to distribute this 2 to everything inside this grouping. So it's all in perspective and how you want to work it. Technically, you're supposed to combine your like terms right here. So let me take this step and get my 6x plus 9. And then let me distribute the 2 to each term inside and get a negative 2x squared minus 12x minus 18 minus 1. So you can see that when we combined our last two like terms, which is negative 19, that gives us our y-intercept, our quadratic in standard form, which is our answer. We have reached the end of part 1. You are welcome to watch this video again if you'd like, but your work time for the first half of class is to work on problems 1 through 16. I do have the answers posted on Canvas so you can check your work as you go along. Please feel free to work with your partner and ask questions. If you happen to finish part 1 early, please feel free to go ahead and start on part 2. Good luck and thank you.